We're going to talk here about slope. Remember, slope, we use the variable m to talk about slope, and that would be rise over run. Or if you have ordered pairs, that'd be the second y value minus the first y value over the second x value minus the first x value. Some things to remember. Slope is positive if the line is rising from left to right. The slope is negative if the line is falling from left to right. The slope is 0 if the line is horizontal. And the slope is undefined if the line is vertical. If lines are parallel, they have the same slope. And if lines are perpendicular and cross at a 90-degree angle, then their slopes are opposite reciprocals of each other. In example 14, they want to know, is it positive, is it rising, falling, horizontal, or negative? And then they want to know what the slope is. This is rising from left to right. And if we count the rise, it's up 1, 2, 3, 4. So the slope has a rise of 4 and a run of 1, 2, 3. So 4/3 is the slope. This line is falling from left to right. And if we count how far down, this isn't the best graph. It's going down 1, 2, 3. And so that's a slope or a fall of -3 and a run of 1, 2, 3, 4, 5. So -3/5. Here we've got an x and a y, an x and a y. We can call this point 1 and this point 2. So the slope would be y2 minus y1 over x2 minus x1, which gives me -3 over 4. -3/4. Here, let's label it x1, y1, x2, y2. So y2 minus y1 over x2 minus x1. 5 minus 2 is 3, and on the bottom we get 0, which is an undefined slope. So if I were to graph C, it would be falling, and if I were to graph D, it would be vertical. If I get 0 on the bottom, it's undefined. If I get 0 on top, then it's 0, and it would be horizontal. Example 15, we've got two ordered pairs, which describe two different lines, and then they want to know, is it parallel or perpendicular? So let's find slope 1. That would be 4 minus 7 over 0 minus 1, which is -3 over -1, which reduces down to +3. Slope 2 for line B, we're going to have 3 minus 4 over 3 minus 0, which is -1 over 3. These are negative reciprocals of each other, or opposite reciprocals, so this is perpendicular. These lines are perpendicular. You're going to see linear equations written in multiple forms. One form is in standard form, where x and y are on the same side and equal to constant. The form you're most familiar with is slope-intercept form, where y is by itself. The number in front of x is your slope, and the constant being added or subtracted off to the side is where it crosses the y-axis, your y-intercept. So graphing these lines, this is in slope-intercept form. The negative in front of the x tells me that my slope is -1. We can turn that into a fraction, so it'll be fall 1, so rise over run. It'll go down 1 and go over 1. And then the -2 is telling me that my y-intercept is -2. So we usually start with our y-intercept, make a point at -2 on the y, and then from that point we go down 1, right 1, and we can keep going down 1, right 1. You also could go up 1, left 1 for the negative, and then you connect the dots with a straight line. In 17, you can find your x and your y intercepts, like we did in example 1, and plot those and connect the dots. Or you can put it in slope-intercept form and get y by itself. So if you subtract 5x to the other side, and we're rearranging the equation here, divide by the 2, we can get it into slope-intercept form. And then from there, we would start with our y-intercept of 5. So it starts at 5. And our slope of negative 5 over 2 tells me I would go down 1, 2, 3, 4, 5, and right 1, 2. And I can do that again, down 1, 2, 3, 4, 5 over 2, and connect with a straight line. And so that's how you would graph 17. On this side, again, we've got slope-intercept form. This is writing equations. So I've given you the slope and the y-intercept, and I want the equation of the line in slope-intercept form. So we would write y equals 1/2 x minus 5. There's your equation. Got two forms here, point slope and slope slope. We don't really see slope slope very often. What we're going to use a lot in calculus is this point slope equation. And so you need a point, which is your x1 and your y1, and you need a slope. And then you just plug them into this, this form. Write an equation with this point and this slope. So they're giving you m and x1 and y1. So if we look at our point slope equation, it'd be y minus the 2 equals negative 1/4 for m, x minus the 4 for your x1. And then if we want to get y by itself, we would distribute the negative 1/4, which here, that's going to give me positive 4/4, which is 1. And then add 2 to the other side. So in slope-intercept form, that's negative 1/4 x plus 3. For example 19. Example 20, they give you an x and a y, and they talk about a slope. So they say it's perpendicular to this line. Well, this line has slope negative 2. But a perpendicular slope, we would change the sign to positive, and we would flip to upside down, the reciprocal. So my slope is going to be 1/2 for the new line. So y minus the y they give you, our new perpendicular slope, and then x minus the x they give you. And then let's get y by itself. That's going to change to positive, distribute your 1/2, and then we're going to add 4 to the other side. So if I add 4 to 1/2, we're going to need a common denominator there. So if I put a 2 on the bottom and a 2 on the top, that's going to be 9/2.